Good morning, students. In last class we have done Dalton's law of partial pressure, and today we'll do some numerical based on this Dalton's law of partial pressure. So question number 1, a mixture of 28 gram of nitrogen gas and 64 gram of oxygen gas occupies a volume of 0.008314 meter cube at 300 Kelvin. Calculate the mole fraction of each gas in the mixture and their partial pressures and the total pressure of the gas mixture. So this is your numerical. A mixture of gas is present, 28 gram of nitrogen gas and 64 gram of oxygen gas, and this mixture contain a volume of 0.008314 meter cube. Temperature is given at 300 Kelvin. Now first time we have to determine the mole fraction of nitrogen and oxygen gas, and what about their individual pressures, I mean the partial pressures, and the total pressure of the gas mixture. So first time we will determine its number of moles to determine the mole fraction, because mole fraction is determined from number of moles. So number of mole of nitrogen gas, which is represented by N of N2, number of moles of nitrogen, given mass by molar mass. Your given mass is 28 gram. Molar mass of nitrogen gas is also 28 gram per mole. Ultimately we will get 1 mole. Similarly, number of mole of oxygen gas, which is represented by NO2. This is equal given mass of oxygen 64 gram. Molar mass of oxygen is 32 gram per mole. You will get 2 mole. Gram cancel, unit goes to mole. Now you can determine the mole fraction. So mole fraction of nitrogen gas, which is represented by chi of N2. This is equal number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of oxygen. I mean 1 by 1 plus 2. So you will get 1 by 3. 1 by 3 means you can write 0.33. Mole fraction do not have any mole, I mean unit. Similarly, mole fraction of oxygen gas, which is represented by chi O2. As you know, summation of mole fraction is always 1. So that is why chi O2 1 minus you can do chi of N2. I mean 1 minus mole fraction of nitrogen. So this is equal 1 minus 0.33. You can write 0.67. So this is the mole fraction of nitrogen gas. This is the mole fraction of oxygen gas. Now we will determine the partial pressure. Before determining partial pressure, you should know about the total pressure, because you have got the formula. Partial pressure of any gas is equal mole fraction of the gas multiplied by the total pressure. So first time we will determine total pressure. As you know, PV is equal nRT. So the total pressure P is equal nRT by V. N means number of moles of the mixture. 2 mole, 3 moles, 2 mole plus 1 mole, you will get 3 moles. Volume is given 0.008314 meter cube. Since the volume is given in SI unit, so the value of R also you have to use SI unit value. 8.314 joule per mole per Kelvin. Temperature is given 300 Kelvin. So mole per mole cancel, Kelvin inverse, Kelvin cancel. So this equal you can write 3 into 8.314 into 300 divided by this one. If you write as 8.314, then you will get 110 to the power minus 3. Unit goes to joule per meter cube. As you know, joule means what? Joule means you can write Newton into meter. So this 8.314 cancel. You will get 900 into 10 to the power 3. You can write 9 into 10 to the power 5 Newton per meter square, and Newton per meter square you can write Pascal also, PA. So this is the total pressure of the gas mixture, 9 into 10 to the power 5 Pascal. Now we will determine the partial pressure. So first time you determine number of mole. After determining number of moles, you can find out mole fraction. After determining mole fraction, you determine the total pressure by using ideal gas equation. And when you get the total pressure, just to multiply mole fraction with the total pressure, you will get the partial pressure of the gas. So to determine partial pressure of the gas, partial pressure of nitrogen is equal mole fraction of nitrogen multiplied by total pressure. Mole fraction of nitrogen you have got 0.33. Total pressure 0.33 means 1 by 3. Total pressure you have got 9 into 10 to the power 5 Pascal. So ultimately you will get 3 into 10 to the power 5 Pascal. And this is the partial pressure of nitrogen. Similarly, partial pressure of oxygen is equal mole fraction of oxygen multiplied by total pressure. So this is equal mole fraction of oxygen you have got 0.67 2 by 3 into 9 into 10 to the power 5 Pascal. So you can write 6 into 10 to the power 5 Pascal. This is the partial pressure of oxygen. You know, summation of partial pressure gives the total pressure. Total pressure is 9 into 10 to the power 5. So when you add P of N2 plus P of O2, you will get 9 into 10 to the power 5 Pascal. According to Dalton's law, the summation of partial pressure gives the total pressure. So we have determined number of moles. After determining number of moles, we determine their partial pressures and the total pressure also. Thank you.